All right, so we're on day 3 of 9.1, properties of radicals, or just simplifying radicals. Here's a couple of ways that we went over so far to determine if a radical expression is simplified, and then a couple of examples. I'm not going to review. You can kind of pause the video if you need to and then take a look. There's a third way that you could determine if a radical expression is simplified. So the third way that you could determine if a radical is simplified is if there's no fractions underneath the radical, which means if there are fractions underneath the radical, you would need to simplify. So here's my example, the square root of 15 over 64. There's a fraction underneath the radical, or you can also say the fraction is the part of the radicand. So this is not simplified. But here's what you can do. Instead of just one single radical, I could break it up to the square root of 15 over the square root of 64. And you should know from the previous lesson that we can simplify what's in the denominator. I don't want a radical in the denominator. Luckily, the square root of 64 is a perfect square. 64 is a perfect square itself. So I can keep the numerator the same. You actually cannot simplify the square root of 15. The square root of 64 is just 8. And then I don't need to worry about like multiplying the numerator and denominator by the square root of 64, since 64 is a perfect square. This is simplified. There's no more radical in the denominator. I don't have a fraction underneath the radical either. And then on my next example, the square root of 81 over x squared. So there's a fraction underneath the radical. I could first break it up into two radicals, a radical in the numerator, radical in the denominator. Notice I didn't change the 81 or x squared yet, but the square root of 81, that's a perfect square. So we can simplify it. Square root of 81 is 9. In the denominator, square root of x squared. Remember, this square root undoes a square. It's just x. So this radical is completely simplified. There's no fraction underneath the radical anymore. There's no radical in the denominator. We're done. There's actually no more radical. And then on my next example, the square root of 5 over 11. I could break that up and make it the square root of 5 over the square root of 11. Neither of these are perfect squares. So we revert back to what we did on day 2 of 9.1. We need to rationalize the denominator. Here's the radical in the denominator. Multiply both the numerator and denominator by the radical in the denominator. So in the numerator, I could actually multiply the 5 and 11 because both of those are part of the radicand, or they're both underneath the radical. So square root of 55. You actually won't be able to simplify that any further. There's no perfect square factors. The only factors of 55 are 5 and 11. And in the denominator, 11 times 11 is 121. The square root of 121 is 11. Square root of 55 over 11. There's no fraction underneath the radical. There's no more radical in the denominator. And as I mentioned, the radicand doesn't contain a perfect square factor. So those are all the ways that you could determine whether or not a radical is simplified. These 3 ways here, you always have to check to see if there's no perfect square factor underneath the radical, there's no radical in the denominator, or there's no fractions underneath the radical.